Hello, this is Mr. Stansbury. I'm going to take you through the notes on Venn diagrams. At the end of this, you should be able to say, I can illustrate subsets, intersections, unions, and disjoint sets in a Venn diagram. And I am also able to decipher various information from a Venn diagram. Okay, so first things first. A Venn diagram consists of a universal set, U, represented by a rectangle, and subsets within that are generally represented by circles, like this one here. Okay, so the complement, so basically we have set A here, so that's the black part here, and then the complement of set A, which is considered A prime, is the shaded green region outside of the circle. Okay, now subsets. Subsets, we can right now say that B is a subset of A because all of B is inside of A. Okay, B is also a subset of the universal set. Okay, and then let's see some more stuff. Intersecting sets. For two sets, A and B, which have some elements in common, but neither is a subset of the other. So, like, there's some elements that are in A, some elements that are in just B, and there's some elements that are in both would be written like this. So like, let's say if, for example, here we'd have set A would be 1, 2, 3, 4, and 5. Set B, we would say could be, I don't know, -2, 0, 2, 4, and 6. Okay, so if this was set A and set B, let's see, the easiest thing is usually to figure out which one they have in common, which one or ones they have in common first. They both have 2 and 4, so we would write 2 and 4 because those are in set A and in set B. 1 is in just set A but not B. 3 is in set A but not B, and 5 is in set A but not B. And then for B, we have -2 is only in B, 0 is only in B, and 6 is only in B. And let's just say the universal set, just to have a little bit more fun with this, would be -2, -1, 0, 1, 2, 3, 4, 5, and 6. Then all the ones that are not in A or B would be included in the universal set. So we have -2, but -1 is not in there anywhere, so we'd put that there. 0's in there. 1, 2, 3, 4, 5, and 6 are in there. So the only one that's not showing up in there would be, -2 is also in there. The only one not showing up from our universal set would just be -1, so that would be outside. Okay? All right, intersection. Intersection of A and B is what they have in common. That would be the green piece in there. Okay? And then the union is what do sets A and B have in either one of them. So if it's in set A or in set B or in both, that's the union of A and B, and we would write that A union B, A intersect B. Okay? Disjoint or mutually exclusive sets have no common elements. So disjoint, mutually exclusive. So if it's in A, then it can't be in B. That's what mutually exclusive or disjoint means. Okay, so the intersection of A and B on this would be the empty set. All right, let's take a look at an example. We got example 6 here. Universal set is 0, 1, 2, 3, 4, 5, 6, and 7. Illustrate on the Venn diagram these sets. Okay, so first thing we want to do is figure out is if they're all if there's a intersection of them, like if they're sharing some, if they're sharing all. So we kind of got to figure out what do they have in common, basically. So these both have 2's, and they both have 4's, but A has some that are not in B, and B has some that are not in A. So what we want to do is we're going to need to draw circles like so, that have the intersection piece in the middle, and that's a little small. Let's draw those a little bit bigger so we can get our intersection pieces in there. So that's 2 and 4 are in both of them, right? And then just in A is 0 and 6. Just in B is 1, 3, and 5. And then we have to figure out if there's anything that we missed from the universal set. So we have 0, 1, 2, 3, 4, 5, and 6, but we don't have 7, so we'd have to put 7 out here. Okay? B, 3, 4, 6. So 3, 4, and 6 are all in here. So that means what we could do is we could draw a big circle that's B, and inside of that circle would be A, because everything that's in A, 3, 4, and 6, is also in B, right? And then we also have 2 and 5 that are in B that are not in A. And then again, we got to figure out what's going to make up the rest of the universal set. We missed 0. We missed 1. We have 2, 3, 4, 5, 6, but we don't have 7. So that's how we would represent this on a Venn diagram. All right. Set A, 2, 3, 7, 0, 4, 5. These do not have anything in common. So these are disjoint or mutually exclusive sets. So we would go A and B, 2, 3, and 7, 0, 4, and 5. And then again, we got to figure out what is missing from the universal set. We have 0. We don't have 1. We have 2, 3, 4, 5. We don't have 6. So we need 1 and 6 in there to complete that. All right? Okay, let's take a quick little comedy break here, and we'll get back to it.
Okay.
All right, just a little fun to break it up a little bit here. All right, one last set of examples. Okay, on separate Venn diagrams, shade in the regions for each. Okay, so all we're going to do is we're just going to shade in these regions for A. So anything that's in A, we're just going to shade that in. Okay, so if it's in A, that's what we want to shade in. So that's going to be all of this. Okay, so that's shading in A. B is A prime, so that's basically the exact opposite of this. So it's going to be everything else except for A. Okay, so that would represent everything that's not an A. So we add those two things together and we get exactly the universal set. Okay, A union B. So that is what both A and B have in common, and that's just going to be this little middle section right in there. Okay, now we have A prime intersection B. So sometimes this gets a little tricky. So it can be kind of nice to actually go through and figure out what each one is. So let's maybe do some like shading on this here. Okay, so let's do, so A prime is everything that's not an A. We did that already. So that's going to be all of this stuff here, right? So we can shade all that in. I'm going to do this all with one direction. And then intersection of what is in B. So B would be all of this stuff that's in B. Okay. And then what A prime intersect B is what those things have in common. So if we're going to shade in everything that what those have in common, that's going to be all of this stuff right here that does not include that intersection piece right there. So that would be A prime intersect B. That's in both A prime and also in B. Okay. Now we've got A union B. So it's everything that's in A and everything that's, oh, sorry, not union B, but union B prime. So it's everything that's in A and also everything that's not in B. So we don't have, if it's intersect, it's kind of nice to do the shading thing. If it's the union, we can just start coloring everything in. Okay, so let's do that. So we've got everything that's in A. So that's everything in A. And then everything that's not inside B. So that's going to be everything, all the rest of this stuff here. Everything that, except for what is in B, right? So that would be all the rest of this. All right? Okay. A prime union B. So everything outside of A, and then also everything that's outside of B. So let's do everything outside of A first. I forgot about my little bucket, my bucket tool. So everything outside of A would be all of that. Okay. Now, also, we're going to union that with everything that's not in B. So everything outside of B would be including all of this outside stuff here. So the only thing that doesn't get shaded for A prime union B prime would just be the middle part. Okay. So now what this has given us is what is A union B, but the inverse of that, the complement of that, right? So A union B, we don't have A union B. A union B would be all of this and all of that. So A union B would be all the black. So A union B prime is going to be now all of the turquoise that we have in there. Okay? Now, A intersect B. A intersect B is what do A and B have in common, which is just this section right here. But now it says it's the complement of that. So we want to fill in everything except for this section here. So we fill in those and that would be A intersect B, the complement of A intersect B. Okay? And then the last one is we've got A prime, everything outside of A. Okay, so this, since it's the intersection here, we probably want to, let's do a little bit of shading here. So we do everything that's outside of A, right? So that's all this stuff here, including all this stuff in B. So this is everything outside of A. And then we also want to include everything that's in B. So that's going to be this here. And then it's going to include all that. So this whole thing, if we want to get everything, it's where they both cross. And so it's just going to be in that little section there. Let's see if I can get my little, little bucket tool to work here again. All right, there, good enough. So that would be A prime intersect B. All right, okay, that's all we have for this here. If you have any further questions, please feel free to ask in class. Thanks.